Now we're going to discuss geometric sequences and series. We have some vocabulary we need to go over first. Geometric sequence is a sequence in which the ratio of any term to a previous term is constant. What this means is if I have a sequence like 1, 3, 9, 27, and so on, see what I'm doing is I'm taking 1 times 3 to get 3, 3 times 3 is 9, 9 times 3 is 27, and so on. So that 3 that I'm multiplying to get each next term is called my common ratio, which is next vocabulary word. The constant ratio between consecutive terms of a geometric sequence. So if I'm trying to find a sub 2, what I would do is I would take the first term and multiply it by a ratio. That would give me the second term. If I wanted to find the third term, I could take the second term and multiply it by a ratio. If I wanted to find the 99th term, what I could do is take the term that came before that, if I knew that, a sub 98, times a ratio, and that would give me the 99th term. This is a rule for the geometric sequence. The nth term of a geometric sequence with the first term a sub 1 and common difference r is given by a sub n is equal to a sub 1 times r raised to the n minus 1. And now we're going to use this formula on the next example. Example number 1. Write a rule for the nth term of the sequence 4, 12, 36, 108, 324, and so on. And then find the ninth term of this. To go from 4 to 12, I'm multiplying by 3. Multiply by 3 again, I get 36. Multiply by another 3, and I'm going to have 108. Remember, our terms would be a sub 1, a sub 2, a sub 3, and so on. So if I want to find a rule for the nth term, what I need to do first is find the common ratio. So one way to find the common ratio is I could take the second term, and that's equal to the first term times a ratio. So 12 is equal to 4 times r, which means that my common ratio is 3. Now once I have my common ratio, I can find my nth term. So a sub n is equal to a sub 1 times the ratio raised to the n minus 1. A sub 1 is 4, my ratio is 3, and I'm raising that to the n minus 1. And I can simplify this a little bit by remembering my laws of exponents. That's 3 to the n times 3 to the negative 1, because when I multiply with the same base, I add exponents. And this negative exponent means I'm going to do the reciprocal. So this is 4 times 3 to the n times 1/3. And I can simplify this by taking 4 times 1/3 is 4 over 3 times 3 to the nth. So a sub n is equal to 4/3 times 3 raised to the nth. The next part of the problem says that we need to find the the ninth term, and we're going to use the nth term to find the ninth term. So a sub 9 is going to be equal to 4/3 times 3 raised to the 8th. And if I multiply that out, that's going to give me 8,748. That would be my ninth term. Example 2. Write a rule for the nth term of the sequence negative 12, 8, negative 16/3, 32/9, negative 64 over 27, and so on. The next part of that is we need to find the 10th term. If I'm going to find the nth term, I need to remember my formula, which is a sub n is equal to a sub 1 times r raised to the n minus 1. I don't know a sub n. I do know that a sub 1 is equal to negative 12. I don't know r yet, and I don't know what n is. So I need to find r. One way I can find r is I can say that the second term is equal to the first term times the common ratio. So 8 is equal to negative 12 times r. If I divide both sides by negative 12, I'm going to have negative 2/3. So my r is negative 2/3. Now I can find a sub n. A sub n is equal to a sub 1 was right here again, my first term. Negative 12 times my ratio is negative 2/3 raised to the n minus 1. Now just like in the last example, I can simplify this by using my laws of exponents. So this is equal to negative 12 times negative 2/3 to the nth times negative 2/3 to the negative 1, which would give me negative 12 times negative 2/3 to the nth times the reciprocal of this, because that's what that negative exponent means. I need to do the reciprocal. When I do a reciprocal, that still stays negative. And finally, I can multiply the negative 12 times the negative 3/2 to give me a positive 18 times negative 2/3 raised to the nth. Now I need to find the 10th term. So a sub 10 would be equal to a sub 1 times r to the 9th power. So a sub 1 is negative 12 times my ratio is negative 2/3, and I'm going to raise that to the 9th power. Example 3. One term of the geometric sequence is a sub 4 is equal to negative 3. The common ratio is 1/2. We need to write a rule for the nth term and then find a sub 13. First thing I need to do is find a sub 1, because I know that a sub n is equal to a sub 1 times r raised to the n minus 1. So I need to have my ratio. So I've got my common ratio of 1/2. Now I need to find my a sub 1, because that's missing in my formula. So a sub 4 would be equal to a sub 1 times the ratio raised to the n minus 1, which would be 4 minus 1 is 3. A sub 4 is negative 3 is equal to a sub 1 times 1/2 to the 3rd power. So negative 3 is a sub 1 times 1/8. And if I multiply both sides by 8, I get a sub 1 is equal to 24. Now I can take the negative 24 and put it over here in my a sub 1, so I can find my formula for a sub n. A sub n is equal to negative 24 times my ratio is 1/2 raised to the n minus 1. And I can simplify this a bit again by using my laws of exponents. Negative 24 times 1/2 to the n times 1/2 to the negative 1. One-half to the negative 1 is 2. So my formula for a sub n is that it's equal to negative 48 times 1/2 raised to the nth. Finally, to get the 13th term, what I'm going to have to do is use this formula, and I want to find a sub 13. So that's negative 48 times 1/2 raised to the 13th power, and that would give me a sub 13.